All right, one more thing I wanted you to be able to see and refer to as many times as you need. Using synthetic division to factor something completely. So what we're going to do is set up our synthetic division to divide by x plus 1. So we set that equals 0. So the x value is -1 that we're testing. When we get a remainder of 0, that means the x plus 1 is a factor because x equals -1 is a root. Key idea there. If you didn't understand what I just said, rewind that and listen to it a few times. So I do the synthetic division, leaves me with that, which gives me an x squared plus x minus 6. So since x plus 1 went evenly into y equals x plus 1 times the result of what we got when we divided, so times x squared plus x minus 6. But we can further factor that, and doing so gives us this. So y actually equals this. All right, let's see a second example here. Set up the synthetic division. All right, so I do each of the steps. Multiply, add, multiply, add, multiply, add. Remainder is 0. So that means that -3 is a root, so x plus 3 is a factor. So that gives me that result, which if I factor that, gives me this. So that means that since x plus 3 times that would give me this polynomial, y actually equals this. All right, and now that we have the factored form of that polynomial, we can find the roots. We can do all our 5.2 graphing stuff or any of the other stuff that we've done. We now have the ability to do with any polynomial if we can use synthetic division to start with a factor.